Hello people, in this video we're gonna talk about primitive and non-primitive variable types in JavaScript. And why is it important to know them, let's say, because in JavaScript, variables you can do a lot of things with it and it works, let's say, but it's not the case. JavaScript does things under the hood in order to optimize performance. The reason JavaScript is fast, there are reasons behind it. And those reasons, when you're building a big project, come to the picture and fuck your project. So let's see what are those reasons. So we will be first doing some examples with primitive variables, vars, let's say, and then we will be doing it with non-primitive variables, let's say. With the primitive, it's very simple. When we say primitive, we mean like numbers like 22, we mean name, which is string, like my name Ajmer, and we can have boolean like married, unfortunately false, and we can have undefined, something nothing like any, and you can give it undefined. So these are all like primitive datas, very primitive. So these datas, they don't have anything within them, let's say. They don't, you cannot put something in undefined, right? It's undefined itself is like that's it. But in non-primitive data types, those are data types that within them we have primitive types. So they're like a wrapper or a box in which you can put primitive data types. And the common ones in JavaScript, you have like objects and arrays, like an object of nums like 1, 2, 3. So this is an non-primitive data, and you have like a user, like with name Alex and age 22. You can see in this one you have numbers inside them. These numbers are, you see, these are primitive data types. In the user also, you have got string and you've got number. But the thing with array and object, in array, they are like in a list. They're not labeled. But in object, they're labeled. Like this string is labeled name, and this number is labeled age, right? Now it's clear. Now let's come to the weird side of it. For example, you have got a number, let's say number 22, and you want to, let's label it as number 1, and you have number B is the copy, you want to save number A in it, right? If I log number A and B, what would I see? Let's say number A and number B. I'm gonna log them. What would I get? No test.js. So as you can see here, this is what will you get in the console. You'll get number A is 22 and number B is also 22, right? Let's edit only number B. Number B, I'm gonna increment just 1 to it. Very simple. Now let's run it again. What would you get? Number A is still 22, but number B is 23, right? This is the way you think it is, but it's not the case with the non-primitive data types. Let's work with only this example, this user example. This is user A, right? And you want to create user B, right? And you want to say, I want to have the same thing as user A, just I would like to change the name. Or first, let's just log it for the sake of example. So let's say user A and user B. I want to log them on the console. Let's see, what would you get? You get 2 objects in the same properties, keys, and values. So if I change user B dot name like John, Now, if I run the code, what would I get? You would get John and John. You see, it means user A and B, their both name has changed. Why is the reason? Is very simple. Non-primitive data types like object and arrays in JavaScript, when you save something and you like when you create a variable and you save an object to it, you don't save the object, I mean these values in it. You just save the reference to this object. So simply I copied the reference, like the location of this data, this object in the memory is like it is like on the right side of, let's to make it simple, it's on your right side. So you come down and you say on the right side, whatever it is, save it, the reference of right side, save it in the B. When you mutate and change B, whatever is on the right side, it should be changed. So when it's changed, these both value, because they're referring to the same data, and the data is changed, then you will be having it changed. The same thing applies with arrays also. Let's do it. Let's do as an example. This was with object. Let's do it with an example, like with an array. For example, you have nums, let's say. Nums, let's say A, it's 1, 2, 3. And constant nums B is nums A. And in the nums B, I would like to do something, let's say. Only in the B. I would like to push 4. Now I would like to log both of them, nums A and nums B. What would I get? Let's run it. You see, this both arrays are changed because I told you when you copy here or when you label a reference, you save here the reference, not the value. But in primitive data types, you have the value here. When you want to assign number B to number A, this value is being copied, not the reference to this value. So this is how it works. So what happens, how do you copy, let's say, an object or an array? There are different ways. Like one of the way is destructuring. Like here, if I destructure all the values of num A to num B, then I will be having a new copy of these values, not the reference, like this. Num A. So now you're extracting all the values and you put them here in this new array and you save this new reference here. Now if I run the code, I will see the normal result, which is num A is 1, 2, 3, 3 and num B is 1, 2, 3, 4. This is one solution. But again, sometimes you have, like you don't have an array of numbers, you have an array of objects, right? And you want to have a copy of it so that in case in num A, or let's think of it as a users array where you have objects of users and you want to make a copy of them, and this copy you would like to bring changes to them without bringing changes to the real data itself. So in that case, you need a deep copy. This is a superficial or shallow copy. Let's do it as an example and you'll see the result. For example, you've got users is an array of user, like only name, like Alex. Just 3 would be fine, like Alex, John, Smith. Let's say. So now I would like to copy these users. Let's say copy of users. Users copy users. So now, for example, in the users, this first user in the copy, I would like to change this Alex to something else. So I would say user.copy, in the first element of it, in the first element, the name, I would like to change it to something else, like Alexander, or let's say Ali, right? So now I would like to log users, the first user. You run it, you get Ali. You see, this users is not expected to change, but it's changed because I told you it's a shallow copy. It's a shallow copy when you have deeply nested object. This is not the solution. So the solution would be to make a deep copy. One of the common way of making a deep copy using is json.parse, json.stringify, and you put users. So this is a trick. You change these users to a JSON, like a JSON object, then you parse it again and bring it back and convert it to normal JavaScript object. Now if I run, I will get Alex. You see, I will get Alex. Now whatever changes, if I'm going to bring any changes to users copy, it's not gonna change users. So this becomes tricky when in some cases, for example, you want to do something with users and you want to like if I say find avg age or something, and you pass like in this function the user, you pass them here, and you do something here with the users, right? Something blah 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 blah, like this, like user 0 dot name, and you say no. You do some changes here, and as a result of which you don't want to change the user, you just want to do something only in this scope, and as a result of which you want to have this array to be not to be mutated or not to be changed, but at the end of the day you get something like this. So the best thing is you make a deep copy of it, and then you pass it to the function and you let the function do whatever it does with it. So this was primitive, non-primitive data types. So it is like you have to understand that there are things that non-primitive data types does in JavaScript to optimize performance. It doesn't want to let users copy this a lot of data over and over again. So if you're if it's like primitive, then your program would copy all the object in arrays, which mostly are big type of data types, and this will increase the performance of application.